Installing Eaton Surge Protector, model CHSPT2ULTRA, with 4 AWG 12 lead wires. Instructions say to wire these to neutral, ground, and a 2-pole 50 amp breaker in the subpanel, squared Q0816L100S, but the 50 amp breaker terminal is only listed to accept AWG 8 to AWG 2 wire on its box lugs. Can I attach the surge protector's AWG 12 wires, or does this violate NEC? Second question, if I want to backfeed the subpanel through the same breaker, can I wire the surge protector's AWG 12 wires to the subpanel's fixed main lugs, which are listed for AWG 8, AWG 1? If either of these violates NEC, can you suggest an NEC compliant solution?
Hello and welcome to Just Answer. My name is I will be happy to assist you with your electrical question. 1. The surge protector connecting wires do not carry supply current. Instead, they carry only short duration currents that are associated with a transient event. Thus the reason the model comes factory installed with the smaller 12 AWG conductors. 2. The use of 12 AWG conductors terminating to the 50 amp breaker does not violate the NEC in this application, since this is what the manufacturer instructions call for. Since the surge protector will not have any supply current on it and it is stated in the instruction sheet, this is how Eaton remains NEC code compliant. 3. On a residential panel, 120-240 volt, single phase, all surge protectors are always installed to a 2-pole branch circuit breaker and never to the panel main lugs. Label the 50 amp breaker inside the sub-panel directory as surge protector to identify the branch circuit. If you have any additional questions, just let me know and I'll be glad to answer them for you. Otherwise, don't forget to rate me before you log off. Thanks. Kevin. Since the Eaton Surge Protector is UL certified and tested by the Underwriters Lab, it meets the following definitions located in Article 100 of the NEC. Therefore, you are code compliant. NEC, Article 100, definitions identified, as applied to equipment. Recognizable as suitable for the specific purpose, function, use, environment, application, etc., where described in a particular code requirement. FPN, suitability of equipment for a specific purpose, environment, or application may be determined by a qualified testing laboratory, inspection agency, or other organization concerned with product evaluation. Such identification may include labeling or listing. See definitions of labeled and listed. Labeled equipment or materials to which has been attached a label, symbol, or other identifying mark of an organization that is acceptable to the authority having jurisdiction and concerned with product evaluation, that maintains periodic inspection of production of labeled equipment or materials, and by whose labeling the manufacturer indicates compliance with appropriate standards or performance in a specified manner. Listed equipment, materials, or services included in a list published by an organization that is acceptable to the authority having jurisdiction and concerned with evaluation of products or services, that maintains periodic inspection of production of listed equipment or materials or periodic evaluation of services, and whose listing states that either the equipment, material, or services meets identified standards or has been tested and found suitable for a specified purpose. If you have any additional questions, just let me know and I'll be glad to answer them for you. Otherwise, don't forget to rate me before you log off. Thanks. Kevin.
Great answers, but could you clarify this issue? I understand that this is a Type 2 surge protector that requires connection through an overcurrent protection device, OPD. There is already a 50 amp breaker at the service entrance panel feeding the sub-panel on which I'm installing the surge protector. This surge protector is local to this sub-panel to protect some special electronic equipment. Would that break satisfy the OPD requirement and allow me to backfeed and use the subpanel main lugs for the surge protector? If not allowed by NEC, is it because this is not an acceptable configuration or just that the main lugs are not listed to accept the 12 at AWG wire in this case, i.e., no instructions from Eaton? The reason I prefer to have a main breaker is to shut off everything locally at the subpanel in an emergency by untrained personnel, but I don't have enough breaker positions to dedicate 2 breakers, backfeed and surge protector. I understand why you wouldn't use the main lugs on a service entrance panel.
1. The surge protector can either be installed at the main panel or at a sub-panel, or a surge protector can installed in both panels. Just depends upon the protection that you require. 2. Sounds like the panel is maxed out in terms of available breaker spaces. Take a look at the panel listing label and see if the panel can accommodate tandem breakers. If tandem breakers are allowed in the panel, you can reconfigure a few of the single-pole 120-volt circuits and swing them over to tandems, which will free up space for the full-size double-pole breaker. Another option, if you have available space, is to install the surge inside the main panel and not the subpanel. If the surge is installed in the main panel, the downstream subpanel will still be protected. However, for the best surge protection, it is always recommended to have a surge installed in each panel if available in your budget, and if you have sufficient spare breaker slots. 3. The main lugs on any panel, whether a main service panel or a sub-panel, are only allowed in the NEC to accept and terminate either service entrance conductors or feeder circuit conductors. It is a code violation to double tap any circuit breaker and or main lug conductor terminations unless it is listed. Very few manufacturers will list and allow double tapping on lugs and or OCPDs. 4. Surge protectors are always installed using an overcurrent protection device, breaker. The 50-amp breaker in your main panel is only for the feeder circuit that terminates to the subpanel. The surge protector breaker is considered as a branch circuit and not as a feeder circuit. Thus the reason why surges are always terminated to a branch OCPD. Branch and feeder OCPDs are 2 different things. Code requires that all conductors have overcurrent protection. Thus the reason for the branch circuit OCPD. If installing and double tapping on any main lugs, this would also void the UL listing and manufacturer warranty of the product, since it was not installed according to the manufacturer instructions. Thank you for the positive service rating. Much appreciated. If you have any other questions, just let me know. Take care, and have a great evening. Thanks again. Kevin.
I understand the feeder/branch circuit difference, but wasn't clear on the OCPD difference with regard to the surge protector. So you're saying the main lugs can't be used, even if they are not double tapped, no feeder on them at backfed, because the surge protector must be on a branch circuit with its own OCPD, and that the feeder breaker can't be used to satisfy the surge protector's OCPD requirement. If I got that right, then we're done. No problem on your rating. Your answers were very clear, accurate, and had the level of detail I needed. You have a great evening too. Regards, Ray.
No problem, Ray, glad to assist. Let me know if the following helps explain things a little better. 1. Yes, that's correct. Since the surge is technically considered as a branch circuit and not a feeder circuit, it must have immediate OCPD protection directly at the panel it is installed in. That is, the 50-amp double-pole breaker in this application. 2. Keep in mind that breakers are installed to only protect the wires that are terminated to them. Thus the feeder breaker is only there to protect the feeder circuit conductors extending downstream from the main panel to the subpanel and nothing else. 3. Since the surge protector is technically considered as a connected load even though it is not carrying supply current but is carrying supply voltage, there still can be either a short circuit and/or a ground fault on the surge conductors. In addition to an OCPD protecting the wires, the OCPD will also protect the surge protector from any short and/or ground fault and immediately trip if that ever occurred. Thus the reason why surges are always protected with an OCPD branch directly in the panel they are installed in. Thanks again. Kevin.
Hi Kevin, I wasn't sure about how the surge suppressor wiring in OCPD was handled, branch or feeder, but your explanation makes it clear, so I now understand what my options are in this case. Your last response was key and all 3 points really cleared up the details that I was looking to understand. Looks like I'll go with the standard main lug-fed configuration with the surge suppressor on the 2-pole breaker as its instructions specify and no back-fed breaker for simple emergency shutoff. Out of curiosity, I have one related question, if you have the time. If not, it's not a big deal. This is just for understanding and not a real issue. If the subpanel were fed by a smaller breaker, say 40 amp, can I still use a 50 amp breaker for the surge suppressor OCPD, or would I need to reduce that to 40 amp? Anything 50 amp or smaller is allowed by the surge suppressor instructions, with correspondingly reduced surge protection capability. It would seem unusual but acceptable since all feeder/branch conductors are still protected. The intent is to provide the most surge suppressor protection capability to the subpanel. If I have any future questions, I'll be sure to request you. Thanks again, Ray.
No problem, Ray, glad to assist. 1. Here is how subpanels work. Subpanels, whether a main lug type or a main breaker type, are rated for maximum amperage. Of course, the amp rating on a main breaker panel will be its maximum amperage. The subpanel feeder breaker can be smaller than the subpanel amp rating, but never larger than the subpanel amp rating. A common example of this would be to have a 50 amp feeder breaker installed in a main panel and then have a 100 amp main breaker panel as the subpanel. In this example, the 50 amp feeder breaker installed in the main panel will be the OCPD that protects the subpanel feeder conductors, and the 100 amp main breaker in the subpanel will only act as a means of disconnect for the panel. If an overload were to occur on the subpanel, it would be the 50 amp feeder breaker installed in the main that would trip and not the 100 amp main breaker in the subpanel. 2. Since the Eaton Surge can be connected to either 15 or 50 amp breaker, depending upon the surge model, I would say that the feeder breaker would need to be a minimum of a 50 amp breaker. Eaton does not state this in their instructions, but my reasoning is that if maximum current protection is required as in the Ultra model, then the feeder circuit would need to be the same size or larger.
Thanks for the reply, Kevin. I understand the subpanel OCPD requirements better now, so how about this line of thought? Surge suppressors seem to be a unique case since a 50 amp breaker is allowed to protect the AWG 12 wires of the surge protector because they only handle transient current. In the same way, wouldn't the 40 amp service panel's feeder breaker to the subpanel be allowed to, because it's only a transient current through the feeder from the surge protector? If it's not a transient current, or too long a one, or a wiring short, then the feeder breaker might trip first, which seems acceptable. Assume that I don't care what happens at the feeding service panel with regard to surge protection. I only care about protecting the loads on the subpanel from surges. The idea is to give better local surge protection at the subpanel by using the 50 amp breaker for the surge protector so it will clamp for a longer time before tripping. In the case of a surge, if the transient has enough energy to trip the 50 amp surge protector breaker, then, you're right, it would trip the service panel feeder breaker first, which would disconnect the subpanel from the main panel, thus preventing any further surges at the subpanel. Not a bad thing if you don't mind having the load power go down, more preferable to damage. If the other way around, say 60 amp at main service panel and 50 amp at the surge protector, then the same surge might trip the 50 amp surge protector breaker but not the 60 amp breaker, leaving the subpanel and load still connected to the main service panel, which might still have a large surge happening, and with the surge protector now no longer functioning due to its breaker having tripped. I like the case of the feeder breaker being smaller than the subpanel's surge protector breaker because it actually disconnects the subpanel for surges larger than the surge protector can handle. Seems like a nifty feature, if it's NEC compliant, which it might be due to the transient current nature of the surge protector current. This flies in the face of normal OCPD rules, but it seems this transient current case is a unique situation. Thoughts? Sorry that was so long.
Thank you for the replies. 1. I understand what you're saying as it is somewhat confusing. Most panel surge protectors only require either a 15 or a 20 amp double pole breaker. Since this Eaton model has a larger surge current capacity, it requires the larger 50 amp DP breaker. 2. The Eaton Model Ultra has the highest surge current capacity rating as compared to other Eaton surge panel protectors. Thus the reason the manufacturer requires a 50 amp OPCD and not the traditional 15 or 20 amp OPCD. The Ultra model is the top of the line residential surge protector that is manufactured by Eaton. 3. Keep in mind that whenever not installing electrical products per the manufacturer instructions will also void the product's UL listing as well result in an NEC code violation. For whatever reason, and I assume it is because of the higher surge current capacity, the breaker must be a 50 amp due to the product rating. 4. In addition, a surge protector is nothing but a glorified voltage filter which upon a surge, will send voltage directly to ground. The breaker should not trip or overload on a surge. It will only trip upon a short circuit current and or ground fault current since there is no supply current to the surge protector. Only supply voltage, 240 volts, is present at the surge. If and when a surge ever hits the subpanel, the surge protector has internal capacitors which will take the bulk of the surge voltage and send the over voltage to ground as well as filtering out unwanted voltage spikes.
Hi Kevin, I now understand it, so I think we're finally done. I realized that this was a tricky subject, so thank you very much for all your help and have a great day. Best regards, Ray.
No problem, Ray, was glad to assist on your questions. Yes, electrical product installations are not always the easiest to understand and they can be challenging at times. I've been a licensed electrician for 28 years and have been performing electrical, resi, commercial and industrial installs for the past 40 years and I still get confused many times by the NEC. Interpreting the NEC code is often a confusing topic by even the most experienced electricians. Seems like we need a Wall Street attorney at times to interpret and fully understand what the NEC code is telling us on many topics. Over the past 40 years, I have many NEC code articles memorized, yet many other code articles to still learn and understand. In the electrical industry, it is always a learning opportunity. Never a dull moment, that's for sure. Take care, Ray, and have a good evening. Thanks again for your questions as they were all good discussion back and forth. Thus, a learning opportunity for both of us. Kevin.
If you have a home improvement or appliance question and want to chat with an expert now, visit justanswer.com/YTHI.